Okay, moving into question 5, which is another logic question. Quite pretty. So, the two diagonals of the quadrilateral Q are perpendicular. Consider the following statements. One of the diagonals of Q is the line of symmetry of Q, and 2, the midpoint of the sides of Q are the vertices of a square. Which of the statements are necessarily true? Okay, necessarily true is in bold. So, if I just find one counterexample, then that'll be fine, right? Because it says necessarily. It has to be true for every quadrilateral Q. So I just need a counterexample. Okay, well, it's quite easy to construct a counterexample. Like, for example, for one, line of symmetry of Q. Okay, well, then let's say I offset the diagonals a bit. So draw my diagonals first. Okay, that's a good technique. Diagonals first, instead of making the shape. Okay, so let's say I go something like this. Okay, well, then this is a quadrilateral, right? Sort of trapezium thingy, I suppose. And this is perpendicular, but none of the lines are symmetry, right? None of the lines are a line of symmetry of Q. Good, so that disproves one. So 1 is not true, or not necessarily true, I suppose. And 2, the midpoints of the sides are the vertices of a square. Okay, what is a good counterexample? Well, just draw a kite, right? If I draw a kite, then you're in trouble, right? Because obviously that's a rectangle, not a square, right? Okay, so both of them are disproved, so we could see that answer has to be A, right? Neither of them are necessarily true for the quadrilateral Q. Sweet.